is concerned, and so on. As you go through most of these things, they're not really difficult, but you just have to pay close attention as to what things mean. Okay? And that's kind of the end. So when we're dealing with growth and decay ones, these are going to be, things that appreciate. You're going to talk about depreciation of car vehicles, banking accounts, things like that. So they actually kind of make a little bit of sense as you start to look at them. So what happens here is you get these things that are called growth models. This, being a growth model, kind of makes you think of this: y equals a b to the x. If it's growth, that meant your b value was greater than 1. So growth, excuse me. Does that vaguely ring a bell? Right. And then if you look at what's inside the parentheses, you've got 1 plus r. So how are you going to get your greater than 1? Well, here's what these things mean. A is your initial amount. How much you start with. R is your rate. It'll be as a decimal though. A lot of times they'll say the rate's 4%. If it's 4%, it means it's 0.04. Just remember that in problems they'll usually give it to you in terms of percentages. You just have to convert it, which I'm sure most of you guys have no problem with. And then lastly, T stands for time, and it's usually years. Okay. It's usually in years. So what happens then, we just start pulling pieces apart. For example, if I'm looking at one like this, if I have an initial amount, if I have a function of y equals 1700 times 1.07 to the third power, that means what's your initial amount? 1700. What was my rate? 7%. And how many years was this for? If I'm saying years. 3. That's what the stuff looks like. Okay. It is very straightforward. All right. So we have growth. So it's y equals a 1 plus r. Excuse me. To the t. Let's look at our problem. For example, population. The population of Winnemucca, Nevada, is modeled by blah, where t is the number of years since 1990. What was the population in 1990, and by what percent did the population increase each year? So if I'm reading that, year 0 is 1990. That's when you start. Okay. So if year 0 is 1990, that means what's your value of t? 0. So what's anything to the 0 power? 1. So what's your initial amount then?
6,191.
Or one of those. Yeah. It's that pretty straightforward, isn't it? Okay. So if you looked at this, take your calculator out real quick. And this is where table stuff is going to come into play about helping you figure out what certain things can occur. And let's put this one into our y equals. What was it? 6191 parentheses 1.04. And instead of doing 3, because I put 3 in there, it's just going to kick me out a number. It's just going to be linear. I'm going to change that time variable to, the time thing to x. That way we see what's, oops, sorry, I forgot to do the power to the x. So I'm going to type it in like that. We okay with that? Go to your table. Remember, second table. My table right now is starting at -7. No big deal, I just have to move it to year 0. Now, that means at year 0, we started with 6,191 people in the beautiful town of Winnemucca, wherever, Nevada. So for every year forward, year 0 is 90. What's year 2? No, I'm asking, what is the year? So if I wanted to say, hey, what was the estimated population in 1997? You'd have to look at 7, exactly. So that's what you're kind of looking for. The idea is that year 0 is where you start, and then if you're looking at year 97, 90 is year 0, 91, 92, 93, 4, 5, 6, 7. You just have to count some of these things. So if I'm looking for it in year 7, I just scroll through, and it says that I have 8,146.9 people. Can you have parts of people? I mean, you can, but it's a little messy. So, I don't know if you guys ever saw the movie Body Parts. It was a horror movie. It was terrible. I just remember there was a car crash, and the guy, the bad person in it, was out there looking, trying to get body parts because he was a mass murderer that they tried to kill, and then he escaped from jail, but they went after other mass murderer body parts. I remember he got in a car accident, and he got out of the car, and it was like the scene from Godfather. Leave the gun, take the cannoli. But he went and looked for the arm out of the back seat. He opened up the door and grabbed the arm right away. It's a great movie.
There's a horror movie about my hometown, so
Yeah.
it's not good.
No, it's just bad.
Like 2 stars.
Yes. Body Parts, I don't think it was even half a star. It was just like a blink.
It's like, no.
Yeah.
No.
Anyway, you see what I'm getting at here by putting this up in the calculator. You'll use the calculator a lot to bounce back and forth. A lot of these questions will ask you to graph something. You'll never graph these. I'm never going to have you guys graph one of these word problems because it's just awful. More often than not, we're looking at, it'll say graph and estimate where something happens. Well, that just means use the table. We'll just say that because this textbook also was written before a lot of the graphing calculators, before we had a lot of the fancier stuff. So, no big deal. Okay. Here's the other one that talks about money, banking. And I think we kind of alluded to just a brief discussion of this last week when you're talking about compounding interest. Do you guys remember me talking about that?
Yes.
So savings accounts, things along those lines. Interest compounds, and it depends on how much it compounds as to how much you're earning back. So what happens is when you're dealing with banking in terms of a growth model, you have what's called your principal. Principal is the amount that you invest, the amount that you deposit. So P stands for the principal. So if you're putting in, $500 into a savings account if your child was born, you give them $500 and see let it grow for 18 years. They have a little nest egg for college, that kind of thing. Now, inside the parentheses, again, this is still going to be a growth model because if you look at it, it's 1 plus something. Okay, so your B value, all that stuff in parentheses is going to be growth. You wind up with 1 plus. Again, your R value is your rate as a decimal. N stands for the number of times it compounds. So if it compounds annually, how many times does it compound? Once. Semi-annually. Quarterly. Monthly. Daily. Okay, things like that. You could go hourly if you wanted to. All right, and so on and so on. And then obviously again up here it's N and T up top. Okay. Now this more things compound, and this is where we talked about where it approached the E value. Remember last week we looked at the slide that had the as N approaches infinity. That's where it started approximating to the E value when we talked about E to the X, that kind of stuff. That's where this comes from. The more things compound, the more the greater the number of times something compounds, the greater it's reaching, it approaches that value of E. So, and I'll show you an example of this with some really easy numbers here. So what happens is you deposit $1,000 in an account. It pays 8% annual interest. Love that. Find the balance after I wrote 18 years with the given frequencies, and let's look at it in terms of annually, quarterly, and daily. So this was the example that I was talking about. Let's say you had $1,000 lying around and you had a child, you put it in a bank account for them, that kind of thing. All right. So what happens is if you were annual, how many times does it compound? Once. So we're looking at your total amount, principal, 1 plus R to the N T. We know our principal is $1,000. What's our rate? 0.08, okay. So we have 1 plus 0.08 over 1, and then we're doing it 1 times 18. Now, what's nice about our calculators is that we can really easily change this around, okay, and substitute in values. Since we're setting this up, it is asking us for different values. It's asking us to check what it is annually, quarterly, and daily. What variable changes? N, okay? So all we're doing is this equation 3 different times. Now, when we type this one in, we're going to use our fraction bars, parentheses, and everything. Now, let me do this out. So it's 1,000, parentheses, 1 plus alpha of y equals 0.08 over 1, parentheses, to the 1 times 18. And the reason why I'm typing it in like this is because after I hit enter the first time, I can just go back and overwrite, you know what I mean by that? In the calculator where the ones are, and change it to, what was it, monthly or whatever, okay? So if I hit enter, it gives me how much money we would have after 18 years, $3,996, and how many cents?
1.
I think they'd probably go to 2.
Because the government doesn't like this.
Well, this goes into the whole idea of the movie Office Space. I'm assuming you guys have seen that, right?
No.
Seriously?
Yeah. Sorry.
Really? You guys have never seen Office Space? Yeah, yes, that's that movie. Okay.
I think we should have a movie day.
It's not school appropriate.
We'll just get the
Yeah.
Spanish. They did that in sociology. They watched the rated R movie. They just didn't get the
Okay. Yeah. No. Anyway, I'll just say, by all means, please watch it. But the whole don't give me that. Yes, it's the premise. The premise is when you're talking about banking, obviously your numbers aren't clean, are they? You have all these little hundreds, thousands of pennies and stuff left over. So what they did was they decided while they were rewriting all this code for, you don't even know what Y2K, the whole Y2K scheme is.
I do not.
You know, you guys weren't even born yet, but anyway. So, so the whole idea behind all of that was they thought that the computer systems across the world were going to fail because everything was programmed as a 2-digit date code. They forgot that 1996, when you use the year of 96, as it goes to the year 2000, it switches back to zeros. And they're like, oops. So towards the beginning of the year 2000 or 1999 in that area, people started realizing, oh crap, we have to go back and fix everything. So when this movie came out, amongst all that idea, where they wrote a program as they were doing all this to truncate all those little itty bitty bits of pennies and deposit into an account. And over time, it just compounded out. So they did it for like 6 hours, and they all of a sudden had all this money, and like, oh crap, we're all going to go to jail. And then hilarity ensues, and it's great. It's such a great movie. But anyway.
Is that one of those movies? I'm guessing it's one of those.
No, it's a fantastic movie. It is really funny. It's horribly inappropriate for school. They might swear once or twice in it, so I apologize ahead of it. But I could tell you, but George Carlin does a much better job of it, so please look at his old thing online. But yeah, on Friday, since you have an institute day or you have day off, it's good. It's good stuff. Anyway, so back to this. What was the next one we had to do? Quarterly. What do I have to change? The 1 to if it's quarterly? 4s. Do you guys know how to go back and you just hit second entry and it'll retype it for you? And just overwrite stuff. I'm going to change that to a 4. And it does. It works out nicely. Then there's how much you get if it does quarterly. 416114. Daily, let's see.
What if it's not a leap year?
I don't know.
How many liters?
And then careful, sometimes it might run into some of the next values, so you might have to retype some of it. Oh, thank you. $42.20.03. So if you look at it as it goes annually, quarterly, daily, even as it gets from quarterly to daily, the difference between those two isn't all that much. Okay. So now, if I double daily, that would be what? 730? 365 doubles 730, I think. Does that sound right?
Yeah.
Sure. Watch what happens. So that means it's basically it means it's compounding every 12 hours if we go that way. So if we overwrite that again, what did I say? 730.
Yeah.
Oops. It's not that much of a difference, is it? So even though it winds up tailing itself off, that by the number of times as it compounds, it's going to approach its almost maximum value. Okay, it can't get more than that, and that's where the whole idea of what E winds up going into. This whole concept of E, and you've probably seen this one before. Does that look familiar? The PERT formula? Okay. So this idea of what's called the PERT formula, this is for when you have what's called compounding continuously. The other formula above it is for when it says you compound annually, quarterly, things like that. When it says compounding continuously, think of it as there's a lead, continuously, we have an E button. The P value still stands for the same thing, it's the principal. The R is still the same, T is still the same. So if I look at just this exact same problem in terms of continuously, I would type in 1,000. See next to the number 4 to the left of it, it says LN. That stands for what's called natural log, the log of the natural base. If you do second natural log, it says E. That's your E to the X. That's the button for this. Okay. Second LN. It's right next to the 4, to the left of the 4. Okay. Now, the rate is still the same thing. It's still the decimal value of the percentage. In this case, it was 8%. So if I would just type in for my exponent, I would type in 0.08 parentheses 18, because I'm looking at it continuously compounding for 18 years at 80%. When I hit enter, you'll see it's really close to that same value. Okay? That's where the PERT stuff comes into play. And you'll just see the word compounding continuously. I don't believe you'll have anything besides money that compounds continuously. I don't think I've ever seen a problem that would ever use anything like that. Okay? Does that make sense about the differences there?
Yes.
It's pretty straightforward. Okay? Pretty straightforward. All right, let's talk about decay then. Decay is basically the exact same thing, except the p value, if you will, is now less than 1. Okay, it's between 0 and 1. Remember, when you have a exponential decay, it was y equals a times b to the x, where b was between, it was bigger than 0, but it was smaller than 1. That's where this comes into play. All right. Again, what's called the decay factor is the stuff that's in the parentheses. The growth factor is the stuff that's in the parentheses. A is still your initial amount. Rate is still percent is a decimal. T is time in years. It hasn't really changed all that much. So let's see, y equals a 1 minus r. Depreciation. This is huge with car vehicles, or any vehicle actually. Anything that has that you take off a dealer lot, the minute you drive it off the lot, it's worth less than what you just paid for it. Certain things depreciate faster than other things. Certain things hold value better than other things. It just depends on vehicles, honestly. You probably all heard that before. Your guys' age, you're probably all starting to think, oh, you get a car. You know. Yeah, what's that?
I think that my car is depreciated. Can we do that as a formula of penny?
What do you mean?
Can we take the purchase price of the 1990 Chevy and by the depreciation value?
Yeah, absolutely. You could probably look it up and find what's the depreciation rate on a 1990.
It's too old to go on like you only go down to 1996.
Oh. But if you Google it, I bet you could find it on the Google machine.
I don't know how to do this.
I'm sorry.
I don't know how to do this.
I'm still on the internet.
Yeah, you're an Internet Explorer. I was at 7. Internet Explorer 7, right? All right. So speaking of cars, let's say this: when you bought a new car for 24 grand, and the value of the car decreases by 16% a year. Let's write a model for the value of the car. Use the model to estimate the value of the car after 2 years. Obviously, I cut and paste this problem directly out of the textbook, and it says graph the model, and then use the graph to estimate when the car would have a value of $12,000. This is where using the calculator and the table becomes your best friend. Okay, and we'll show you how all this stuff works. So, what's the initial amount? 24 grand. So our initial amount, our A value, is 24 grand. What is the rate of depreciation? 0.16, good. And it said we're looking at it for T in years. So we would have our Y equals 24 grand. 1 minus 0.16 to the T. And honestly, I rarely, if ever, simplify what's in the parentheses. Okay? Because I'll screw it up. Well, that's just 74. 74, it's 8. That's that kind of thing. Because the calculator can do the work for you. Okay? So what I would do is I would go and enter that into my calculator exactly the way I wrote it. Y equals, let's clear out what we had, 24,000. Biggest mistake you might make, you might miss a 0. And then it was 1 minus 0.16 to the X. And go to our table. Obviously, again, if you look at it, year 0 should be 24,000. All right? As it's going through, how much was it worth at year 2? $16,934. Okay? Now, what happens is when you buy cars, unless you're paying cash, you usually finance them. And have you all ever heard the term underwater on purchases? Okay. So let's say you bought the car for $24,000 and you got a 5-year loan on it. Okay. Generally, between the first couple of years, since you're paying off more interest than you are principal on it, you might owe $21,000 after 2 years of payments because of the way the interest works. The car, after 2 years, I should probably pay less. You probably owe 18. The car's only worth 16.9. So if you traded in that car, you would lose money on it. Okay, you would lose money on it. So that's why when you buy stuff, you try to make sure that you could take a cash hit, which is fine, but you're going to finance something. It's got to be something that you know you're going to take for a while. That way you don't lose out on it. When we traded our trucking, our truck, I think I owed $3 grand left on it when I traded it in, but they gave me so much money for it. I had so much more for a down payment on something else. It's a super common thing. Your folks have probably all done it before, working through it. We're the same idea with houses. About 10 years ago, when the housing market all crashed, everything wasn't worth anything. So all those houses that people bought for $200,000 all of a sudden were worth 100 or 110. And people all lost so much money on things they couldn't afford to move stuff back and forth. So housing came back around, obviously, lately in the past 4 or 5 years, but same basic idea where you lose through. When it gets down to here, the next question on there, it said, what did it say? Estimate when the car has a value of about 12 grand. So here's what I would say. We know that year 0 was here. 1, 2, 3, 4. I would say after 4 years, the car is worth about 12 grand. Does that make sense? So looking for the value of when it occurred. What's that? Okay. Yeah. Obviously, cars will depreciate up to a certain value, and then they're still worth scrap. Yeah.
My dad scrapped his 2 trucks.
Yeah. Yeah.
Like, no one was driving by.
No, they did that also in.
Still have that.
What they do the gas filter one back in 06, 07, where people were trading in like old junky cars and they were getting money for new cars to help get new efficiency standards. Hey. How about this? A stereo system. You buy a stereo system for $780. It's the Alpine, yeah, right? You buy a stereo system for $780. Each year, the value of the stereo systems and fleets are depreciates by 5%. Please write a model that represents said.
We still have that same commercial for the one company that takes.
3 auto wreckers? That old car is worth money.
Yeah. They still have like the same one.
They do. They actually updated it.
Really?
They did. They turned it into a little cartoon version of it.
I just remember the original where like.
The guy with the watch, the big giant watch band and all that.
I remember the opening the door to close off.
Yep. 3 auto wreckers.
I expected that like,
No. So obviously, I'm pretty sure most of you guys haven't bought a stereo system. Most people don't buy stereo systems anymore. They're called sound bars. They're great, you know. So it's January27 parentheses 1 minus 0.05. So that's it. And that's what we're looking at. And again, we can throw values in there and set things up. So I made, instead of trying to go through all the different PDF files and everything, what do you mean? She said. Jeez. So what I did here, guys, was, yeah, I think the one was on there. The stereo one, yeah. There's a couple that are kind of the same here. For the most part on this stuff, I figured you guys are young and your eyesight's decent, so you should. So you should be able to knock out the majority of all this. I don't think there's anything under it that's any crazy. Remember, when it talks about graphing, usually the next question after it says estimate when something happened. So that means hit, use your y equals and go from there. Which also means, are you going to be doing word problems like this without a calculator? No. So this will be definitely the stuff I'd let you use a calculator on.
So it was going to be like calculator.
Correct. Let's make this draft. That's good. We can't read that one. I think on the, what's up?
On Thursday, where it says lead down next to credit, I think we had Thursday using that was on Thursday.
Yeah. Yeah.
What is it?
Good to see you on Thursday.
It's a whole, yeah. Is it not
Yeah, you guys be able to knock out, I'd say pretty much most of this, not too much of a hassle. There's a couple other styles of the word problems that we'll look at tomorrow. I just want to give you guys a basis on some of these things because what will happen tomorrow is that I'll change a few of these things up and I'll say how much money initially has to be deposited to earn so much after so much time, things like that. How do you work backwards through some of the equations? Because if you think about it, there's 3 variables here. We can solve for them. Really, the only one you don't know how to solve. Oh yeah, we can do the t. Yeah. So, good luck.
Is there like
No, these are all straightforward. We'll talk about how to solve for a specific variable tomorrow. I don't think that I just looked through it. I don't think there is one like that one, but it's pretty easy because you think about it. You've got your 2 and 3. This becomes a number. This is your solve for. You just divide by all that. It's easy. What's up?